Chapter 4, okay, polymer. What do you have to know about polymer? First, we have two. Okay, later. Okay. Sorry. Polymer got three types. Thermoplastic, thermosetting, elastomer. Right. Okay. So what you have to remember is thermoplastic can be remolded when heated. Okay. After you heat it, you can remold it again. But then thermosetting cannot be remolded after heating. Elastomer, it has elasticity. Normally, these two has a higher chance to come out in polymer. But polymer is mainly plastic, so they can compare two types of plastic. Okay, but then elastomer will most likely come out in the rubber. Okay, most likely will come out together with rubber. Elastomer. Okay, so example of thermosetting polymer is melamine and bakelite. Okay, melamine and bakelite, they are those hard plastic, okay, that will decompose when heated, so they cannot be recycled. And then for the one they can be remolded, they can be recycled. Okay, then type of polymerization. We have addition polymerization and condensation polymerization. Basically, addition polymerization is for all the plastics, all the plastics. And then condensation polymerization is for those nylon, terylene. It is like for your clothes one. Okay, as I told you, C for clothes. Okay, C for clothes, clothing. So these are the examples you have to remember: polyethylene, polypropylene, PVC. At least these three, okay, and in this three. And then you also have to know some general properties of plastic, like why all these people are joining in now? Like what? Hey, can you all tell me some properties of plastic? Like what? What are the properties of plastic? Light, okay, durable, light, and then cheap, okay, resistance to corrosion, heat insulator, and then chemically inert as well. Okay, chemically inert as well. Okay. Then for addition polymerization, it involved one monomer only, one type of monomer, but condensation is more than one type of monomer. And then you have to agak remember terylene and also nylon, how they are combined. Okay, for terylene, for condensation polymerization, they will produce another product. You see, wait, at least two monomer with two different functional groups, and producing a byproduct like water or HCl. So terylene is the one that produces. Terylene is the one that produces. Terylene is H2O. Nylon is HCl. I don't know how can I help you to remember this. So far I got no shortcut yet. You remember yourself, okay? Terylene you use water. Nylon you use HCl. Take out HCl and then you combine them together. You have to know how to draw as well. You have to know how to draw. Later we will have questions like that. And then for rubber, you must remember that the name of the monomer is 2-methyl group 1,3-diene. Only when you remember this name, you will be able to draw it out. Okay. A natural rubber means from the rubber tree. It is easily oxidized by oxygen. Have to remember. Easily oxidized by oxygen. Okay. And then other example is like soft. I think easier one, okay, to remember is soft, easily oxidized, and then cannot withstand heat. Or you can say low heat resistant. At least these three lah. Okay, because later on they want you to compare the upgraded rubber and this normal rubber. So you have to remember these three, because these three will be like the bad thing about natural rubber. So when they ask you, hey, why you don't want to use natural rubber? Then your answer will be, oh, because it's soft, it is easily oxidized, low heat resistance. And then coagulation of latex very important. Coagulation of latex very important. Normally, if they come up rubber, they for sure they will ask you about coagulation, right? Okay, coagulation, we will write the essay together later. This thing, don't forget, it is called a rubber particles. This thing called a rubber particle. The tiny hairs inside the rubber particles is called rubber polymer. If you write the wrong name, then don't have marks already. So what happened is hydrogen ion from the acid neutralize the negative charges on the protein membrane. And then what will happen? They collide and break the protein membrane. So neutralize, collide, break, and then finally they combine. 1, 2, 3, 4. For prevention of coagulation of latex, we use alkali solution. By the way, if we use acid like ethanoic acid, and then when we use alkaline, we use weak alkaline like ammonia solid. The point is most likely the same. First, you got to mention neutralize as well. So first point is neutralize. And then the second point is when it neutralizes the acid produced by bacteria, what happened? The negative charges remained on the protein membrane. When the negative charges remain on the protein membrane, they will repel. When they repel, latex does not coagulate. Okay, and then the next thing will be this word, vulcanization. Vulcanization is the process to upgrade your metal, upgrade the rubber. Coagulation is liquid turns into solid. Vulcanization is upgrade it to a strong rubber. Okay, you don't have to care too much about synthetic rubber. Synthetic rubber, not very important one. Basically, synthetic rubber is just like vulcanized rubber. You can just think of it as the same thing. It will be easier. Synthetic is just vulcanized rubber. They have the same property, like very elastic, not easily oxidized, hard, resist to chemical, or high resistance to heat, like that. Okay, so you don't care about this lah. You just think of it as vulcanized rubber. Then this vulcanization method, I don't think it's important lah. I don't think it's important. But what you have to know is, when a rubber been through the vulcanization process, it gets a better quality. Well, how come it has a better quality? Everything is because of the sulfur crosslink. Sulfur crosslink. And then they will want you to explain why a vulcanized rubber is more elastic. Why is it more resistant to corrosion? Why it has more resistance to heat? These are the explanations that you have to know how to explain. So basically, for elastic, why is it more elastic? Because the sulfur crosslink pull the rubber polymer back to the original position. It's like spring lah. It's like spring. And then, why is it harder? Because the sulfur crosslink make the rubber polymer harder to slide over one another. Just like alloy, hard to slide over one another. Resistance to corrosion because of the sulfur crosslink has filled up the double bond already. 它的 double bond 减少 它就没有这样容易跟 oxygen react 咯。Okay, more resistance to heat. It has a stronger covalent bond of sulfur cross-link. That means it has extra bond between the rubber now. So you need to use more heat energy to overcome the stronger force. Wait, sorry. Yeah, okay, same thing lah. Resistance to heat and melting point is the same thing. Okay, so it needs a higher force in order for it to break down. Just like that. This is chapter 4. Okay, so now let's go through the questions. Let me find the questions. Where this one? Okay, here. Diagram 10.1 shows thread made of nylon used in textile industry. So nylon. Nylon is made from polymerization of mixture of two monomer. State the type of polymerization. So this polymerization will be condensation. Yes, condensation, polymerization. Later I have to do the answer to one can. Draw the structural formula of two monomer. Two monomer. Which page? I don't know which page. This one I take out. I simply take out some questions. Okay. So here, to draw the monomer, you have to know how to separate this thing. How to separate? You find the similar part, NH, NH, and then CO, CO. Then you just cut them out. You just copy. Wait. So you just draw like that. Draw the whole thing out. And then nylon. Nylon, when they make nylon, right, they will take out water or take out HCl. When they combine, they take out HCl. So now you have to put it back up. You have to put it back HCl. Okay, then these two are the monomer already, just like that. Next, draw the structural formula done. State one property of nylon. So nylon is just like plastic. You can say light, strong, what? Can't remember already. Yeah. What? One property, I can get any property. Don't know lah. Wait. Okay, like that lah. Okay. A heat insulator, light and strong. Like that lah. Next. How come I can't remember? Yesterday I can remember a lot. But okay, never mind. Polythene is one of the example of polymer. Polythene is widely used as a plastic bag. State two characteristics of polythene that make it suitable to be used as plastic bag. Okay. Why we choose polythene as plastic? So basically, characteristic of plastic bag, you just have to give the properties of plastic bag. We choose it because it's light, it is strong, impermeable. Plastic bag, you want to put your soup when you tap out, impermeable, and then chemically inert. All this you can write. Okay, and then these questions want you to give two ways to reduce pollution. So how to reduce pollution caused by plastic? Every time when they talk about environment, how to save the environment? You can always give the 3R law. Okay, reduce the usage of plastic. Okay, and then recycle them law. And then like what Yashi said, use biodegradable plastics, or you can say use paper bag. Use paper bag. Also can use paper bag means you are using biodegradable plastic. Okay, So just like that. Or you can say dispose the plastics with a proper way, like what? How do you do it instead of open burning? What should you do? Recycle. Okay. Then yeah, here comes the latex and rubber. Latex, when I add solution X, it turns into rubber. So what is solution X? What is solution X? Ethanoic acid, okay, weak acid. Of course, other than ethanoic acid, it can be methanoic acid, also can. This one remain as latex liquid form. We use ammonia solution. Ammonia solution. And then what is this process that turns this natural rubber into something vulcanized rubber? Yes, vulcanization. Vulcanization. Then state process Z. How can process Z increase the elasticity? You see, they want you to explain. How does it increase the elasticity? Why is it more elastic now after the vulcanization process? Because of, yes, the presence of sulfur cross-link. Between the hairs is called between rubber polymers can pull the chain back to its original position. Identify solution X and solution Y done. Explain why physical state of latex different when solution X and solution Y are added into the fresh latex. So this is the coagulation process. Physical state, solid and liquid. So you see, when I add solution X, the acid, what happened? You will say, ethanoic acid contains hydrogen ion. Okay, sometimes students will ask me like, hey, when can I write the name of the substance? When do I write X? So when the question asks you to like identify solution X and Y, when you already name it, then you can just use it in your explanation. It's okay one. Okay, it's very normal to do that. Because if you say solution X contains hydrogen ion, then it sounds very weird. So ethanoic acid contains hydrogen ion. Hydrogen ions from ethanoic acid neutralize the negative charges on protein membrane. Now you see me do is a very easy one. You have to practice to write it yourself later. You have to practice to write. Then only you know whether you can write down or not. Because most students, they just look at me, okay, like that, or neutralize, then tomorrow go to exam, shit, forgot already how to write the sentence. Then you GG. Okay, next. After neutralize is what? After neutralize. Yes, collide and what? Causes the protein membrane to break. And then what I say, rubber polymer, rubber particles, sorry. Rubber particles, with one another, and it causes the protein membrane to break. And then, don't forget to write rubber polymer combined with one another. So coagulation of latex occurs. How many points? 1, 2, 3, 4, 5. If they ask 4 marks, you give all 5 points. If they ask 3 marks, you give all 5 points. Okay, They ask 5, right? You give 5, of course. Then. So in AC, it's like that one. How many marks they ask you, you don't really have to care. You just throw your answer, your proper answer in. They will get full marks. When I use acid, when I use ammonia solution, why? You no need to copy. By the way, this thing I will send it into the PC later. You will have all these things. Whatever I wrote, you will have that. Unless you can't understand my handwriting, then maybe you have to write down. Okay, so here, what already? Ammonia solution contains hydroxide ions. Hydroxide ions neutralize. Neutralize what? Neutralize bacteria? No. Neutralize hydrogen ions from lactic acid produced by bacteria. That means bacteria produce lactic acid. The lactic acid got hydrogen ion, we neutralize it. Then what is the next keyword? Yes. Protein membrane remains negatively charged. Or you can say negative charges remain. Negative charges remain on protein membrane. So what happened? Rubber particles repel to one another. Repel to or repel with, I don't know. Repel with one another or repel to one another. You change it again. So coagulation of latex does not occur. 5 points. 1, 2, 3, 4, 5. So you must prepare this. Tomorrow, if come out in essay like this, tomorrow, Monday come out in essay like this, then 9 marks. You clap first, okay, then you write the answer. You get 9 marks ready. Okay, so question 2. No question, no question, then I go to the next one. Here, what are you doing? It shows 2 types of synthetic polymer that undergoes heating process to study the ability of polymer to be recycled. So they do this experiment is to know whether they can be recycled or not. So they want you to first compare the observation for the polymer A and polymer B after heating. They want you to compare the observation. You see, what is the difference in observation? After heating, it can turn back into a bottle. That means the okay, you see, I teach you how to answer question. What came back question, what example they give you. You think back, okay, you relate back to this thing. Plastic, we got 2 types. We got thermoplastic, we got thermosetting polymer. So this one is thermoplastic, right? So in the thermoplastic parts, what we highlighted just now can be remolded when after heating, and then can be recycled. Thermosetting cannot be remolded after heating, and then cannot be recycled. So I compare the observation. I can say that this one can be remolded after heating. Of course, if you want to write, it's softened when heated, and then it is solidified, or it can be shaped again when it is cold or something like that. It is actually the same thing, remold. You melt it, you soften it, and then you make it into another shape. It's called remold. It's the same word. And then this one, you can say it cannot be remolded, or you can just say that it decomposes when heated. See, I compare back my handwriting last year, or maybe like 2 years, 2 years ago or last year. It's a lot better than this year. I don't know why, or maybe I use typing a lot. That's why my handwriting is like shit now, like even worse than last time. Okay. What do you want? Explain your answer. Okay. They want me to explain. I just put in everything I know, which is this is a thermal. Why this one can remove? Because it's thermoplastic polymer. Okay, and then this one is thermal setting polymer. So this one can be recycled, and this one cannot recycle. How many points already? 1, 2, 3, 4, 5, 6. Everything like 6. Okay, just like that. So I compared the observation, I gave the result. Okay, this one can recycle, this one cannot recycle. Next. The information below shows 2 polymers, terylene and polyvinyl chloride. Can we draw table to answer this? Yes. For like comparison question, you can always draw table A and B. Okay. And don't write point form. In exam, don't write point form. I tell you, I write point form is to show you like how you get the points. You don't write point form. Don't answer 2 questions. Don't answer 2 questions. They say choose one, then you choose one. Ken, in the table, I write point form. Try not to put the point like that. You don't write the point like that. You can write sentence by sentence. Okay, sentence. You don't write the point. Okay, let's say you build a sentence, then your next sentence you write the other line. Okay, no problem. You don't put the dot. Okay. Full sentence in front dot left. Don't put dot. Cannot put dot, because put dot means point form. That's how they think of it. Dash also cannot Dash or point also cannot. As long as it looks like point form, then cannot already. It has to be a sentence form, very pattern one. Damn stupid actually. Terylene and this polyvinyl chloride are polymer produced from different polymerization reaction. State the meaning of polymer. Compare polymerization. Meaning of polymer is a long chain molecule formed by many identical repeating subunits called monomer. If you can do, then you do. Cannot, never mind. So this is condensation. This is addition. Addition polymerization, yes. Suggest another polymer that can be produced from each polymerization involved. So by using condensation, C for clothing, so terylene and nylon. Okay, then this PVC, polyethylene. You can write polyethylene, you can write polyethylene, it's the same thing. Polypropylene also can. Let's say they want you to compare one more difference. Let's say they want you to compare one more difference between the reaction. Other than mentioning the reaction is condensation and addition, you can say it involves 2 monomers. Sorry, 2 types of monomer. This is one type of monomer. And then if they want you to compare again, then you can say it has 2 different functional groups. But this one is only double bond between carbon only. Yes, it produces a byproduct, also can. These are the differences. That means everything we mentioned earlier on in the notes just now. The notes you can find it in the normal class one. Okay, last time we do that one. Everything is in there. Page number 6. Suggest the name of suitable coagulant to speed up coagulation of latex, ethanoic acid. Speed up ethanoic acid. Then briefly, the process involved. This one we done it already lah. Coagulation, the 5 points are. Latex need to be delivered to the factory to produce surgical gloves. As a rubber plantation manager, you are the manager. Which situation in table that is more suitable to be used for the delivery of latex? Justify your choice. Of course, situation B. Why? Why situation B? Why situation B? Use for molding of gloves. No need to remold again. Hey, students, how to explain this? 6 marks away. Then you see, no panic. So you think back. Okay, just now when we go through latex, the only thing I taught you about latex is what? Coagulate. Does not coagulate. So basically, the 5 points are, I mean, the five points of explanation is the 5 points of telling them that the latex does not coagulate. Yes, just the balik. You just write the 5 points of which is, why this one? Or because the anticoagulant contains hydroxide ion. Hydroxide ion neutralizes the blah, 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 blah. So in the end, latex does not coagulate. So that means you have to tell them that I choose B because this can keep the latex in liquid form. Just like that. They won't ask you things like, because I later go to factory already, they solidify, I cannot remove. No need. They only ask you like why you choose situation B. You choose situation B is because it will keep as a latex form, liquid form. We just tell them why we choose this one. We don't have to tell them, we do want it to coagulate because later factory want to do this and that. This is something that you do not, so no need. Just put in the things that you learn. What is the suitable coagulant? Ethanoic acid. Coagulate means make the rubber the latex coagulate. Ethanoic acid. Ethanoic acid. This is ammonia solution. Next. Polymer consists of natural polymer and synthetic polymer. Give one example of natural polymer, please. Natural polymer. Natural polymer. Okay, protein lah, starch lah, natural rubber lah. Can lah. Okay, protein, starch, natural rubber. Okay. Natural rubber, then of course natural polymer. One example of synthetic polymer, I've got a lot lah. PVC, polyethylene, Skip. Write the chemical equation for the formation of nylon. This one. Actually, for chemical equation, they can actually accept for the process of polymerization, they can accept formula, structural formula one. Okay, but then since they say write, then we write log. Okay, how to write that? Okay, see, this is nylon. Nylon take out HCl. Okay, nylon take out HCl. I think I have to find a way for you all to remember. Nylon H2O. Okay, like that. Terylene got double E, right? Then got H, pair with H2 log. Double E, a triple E away. I don't know lah. Okay lah, never mind lah. Double E, double H lah. Okay, just like that lah. Okay. Or you remember, nylon got O already. So here don't have O. And then this one got no O. This one, the other side must have O. Like that lah, pair lah. Take out H, take out Cl. Wait, before that, okay, calculate everything, write it like a normal molecular formula. C6, you multiply it in, C6 H 12 加4 Salute. 16. H16. 6 times 2 is 12. 12 plus 4. 16. N2. Just like that. Plus the other side. C8. 16. O2. Cl2. And then don't forget, I give you one example. Polymerization of polyethylene. Okay, I ask you, correct or not like this? Yes, must have the N, right? Left hand side, we put the N on the left, then this one right side, put the N on the right. So this thing also the same, you know. You have to write N here, N here. That means instead of we balance the equation with a number, we put N. So when you write this as equation, this is how you do it. N C2H4 become C2H4 N. Just put this thing into a formula. So become, you take out 2H and 2Cl. So imagine you take out 2H here, it will become C6H14 and 2. You didn't include 2C. Oh yeah, 10, sorry, got another 2C here, sorry. 10, okay. Then I plus, wait, haven't done yet one. C10, H16, O2, the Cl2 I take out already, take out 2Cl. You plus this whole thing together, it became C16, H30, and 2O2 with the bracket N. And lastly, plus NHCl. Done. Okay. You just take out the 2H that because it's used to balance the Cl2. This 2H and 2Cl. 2H and 2Cl. 2H and 2Cl. Okay, next. What do you want? Draw the structural formula of monomer of natural rubber and give its IUPAC name. IUPAC, monomer of rubber is also known as isoprene. But then now when they want IUPAC, you can't put isoprene. IUPAC is the one that helps you to draw the monomer. 2 metal wood 1,3 diene. Draw it off. Start from 2. Start from wood 1,3 diene. So 1, 2, 3, 4. Wait, the screen is lagging. This is means 1, 3. First and third got a double bond. 2 metal is on the second carbon, put another C. You can write CH3. You can also put it into 3 branches of H. Up to you. And then make sure all the carbon has 4 bonds. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. That can already. Put hydrogen. three characteristics of natural rubber, like three characteristics of natural rubber. The one from the tree, it is soft, yes. Easily oxidized, very good. And okay, less resistant to heat. Or low heat resistance. I think so. Resistance. Cannot withstand heat also can. Easy. Latex obtained from the tap rubber trees will be coagulated. It will be collected immediately to prevent latex from coagulate. Explain how latex can coagulate. So they say you must collect it immediately. Otherwise, they will coagulate themselves. So how to write this one? Wait. Okay. Oh, two different questions. Okay. Yes. So this one, you see how I do it. If latex coagulate naturally, you also copy the 5 points. Okay, I copy. But we change the word ethanoic acid into lactic acid produced by bacteria. That's all. Or lactic acid from bacteria. You just change ethanoic acid into this 1, 2, 3, 4, 5 words. Then everything just copy the same. This is how latex coagulate naturally. Okay. Then another method to prevent coagulation of latex. Then describe one mark. That means you have to add ammonia solution. No? So the method is adding ammonia solution. And then the 5 points. I know it's only 8 marks, but then we just throw everything in. Because if it's 8 marks, they also want to see the same points one. But then they will put these two into one. That means 0.3 and 4 as 1 point. This is what they will do. And then 0.1 and 0.2, 1 point. They still want to see hydrogen ion, but only the marks given is lesser. Okay. Then natural rubber is not suitable for making car tires. Why? Why natural rubber cannot make car tires? The three properties of soft, not resistance, low heat resistance, easily oxidized. Or you can say less elastic also. Okay. Justify the above statement are the three properties. Suggest a process that can be done so that natural rubber can be used to make vehicle tires. Easy vulcanization. Later you read, you vomit again. Vulcanization. Okay. Next. What type of polymerization or thoroughly condensation? Polymerization. Draw the structural formula of the polymer. This one is draw. That is formed by these two monomer. Terylene got no O, so we pair it with H2O. So H2O, you see how? Both also OH. Both also OH. Which one you take out H, which one you take out OH? No different, man. got different one actually. The middle point, actually the middle here, yes, I know the middle is no different. But then your two sides will have different. Your end, the 最左边跟最右边 will have a different. If you take out H, then this one will be, you will have O. If you take out OH, then it's nothing. So got different one. So remember, Terylene is also known as polyester. It's like when you buy your clothes, it says it's made of how many % of polyester. Got a lot of E, you see E, ester, polyester. Polyester is like normal ester made of alcohol and carboxylic acid. When we do esterification, acid we take out H, right? Alcohol we take out OH. That one was my shortcut. Last time I told you already, right? That is my shortcut. Easier to do. But then the actual way is terbalik. The actual way is terbalik. I'm not sure you remember, not sure you remember or not, but in the notes, I give you the proper one and then I teach you the shortcut. So here, you have to think back this thing. You don't use the shortcut. The shortcut is only for the makan with ester. This one you take out H. And then this one you take out OH. Or you can think of it this way. Ester, acid take out H, alcohol take out OH. When it comes to polymer, I terbalik. Also can, up to you. So when you draw it, it's supposed to be something like this. Okay, just like that. You just follow everything only. And then, where n is a large integer, no need, just put n only. N means like an unknown number. So explain why polymer form is also known as polyester, or why this thing is also known as polyester. When people look at this, how they know that it is ester? It is like I'm asking you, when you look at this, let's say I give you a structure, how can you immediately tell me that, oh, this is alkene? How know that it's alkene? How know that something is alkene? Yes, the functional group, the birthmark. Alkene, the birthmark of alkene is double bond. So the birthmark of ester, that means the functional group is what? Carboxylate, COO. Or you can see the functional group of it is carboxylate. Can already. As long as you got functional group carboxylate, then it's enough to prove that it's ester. Okay. Terylene is widely used in textile industry. However, water pollution has occurred due to wastewater disposal. Explain the impact on the environment if wastewater is not well managed. So that means if the wastewater is not treated, 就是你丢出去之前你没有把它弄干净 you throw all the chemicals in the river. Then what happened? Yes, it causes water pollution. And then what? Endanger, I think. or kill the aquatic lives. I think so. Which one? LIVE, I think. LIVE. Which one? Yeah. What? Flash flood. Clog the okay, cannot. By the way, for this one, normally factory water consists of chemical. So normally chemical, it doesn't cause flash flood, but they only cause water pollution. Things that make it clog is the plastic. You simply throw the plastic. Harm human health. Yes, you can say the source of water will be contaminated, will be polluted. Also cannot pollution, same thing. Any other answer, a logical answer can also be accepted. For this kind of environment question, is like, okay, but the use of dyes in batik industry it has caused the river pollution. Make batik, maybe got a lot of ink. How to solve the problem by using green technology? So the meaning of green technology is for this kind of throwing waste into your alam sekitar, and they want you to relate it into green technology, is actually asking you what is the proper waste management you have to do. So it's asking you about waste management. So before you throw the water, it's like it has ink, it has chemical, right? So before you throw it into the river, what do you have to do? Filter. Yes, Jiaxing, very good. The industrial or industry wastewater has to be treated with electro coagulation process or electro coagulation. For releasing to the water sources. This one has two points inside already, right? So the method is electrocoagulation. It can remove harmful substance. Electrocoagulation is I find seagull and all. And then this one. Green tech used to treat water. Electrocoagulation. The most important thing here is electrocoagulation. Okay. Yeah. And then just now I see what I should say. Use natural dye. Also can that are made of natural resources. Okay, also can but okay as long as it is acceptable. Green technology is just something good to the environment. Okay. Next, almost okay, almost finished already. I think just a few more questions. The same question we will just skip. A rubber tapper intends to collect latex in liquid form. However, he found the liquid. This one I skip. How should the rubber tapper overcome this problem? You add ammonia solution and then the 5 points. Okay, this one. An experiment was carried out to investigate the elasticity of vulcanized and unvulcanized rubber. Table 10 shows the result of the experiment. Do you know how they do the experiment? Okay, wait. Let's say. This is the rubber strip. Okay, this is the rubber strip. This is the weight. So they will hang a weight on this rubber strip. And then what will happen? It will be stretched off. So maybe after like 10 or maybe 20 or 30 minutes, they will remove this weight. So just now the rubber has been stretched. So after removing the weight, it will go back to its original shape, right? If it is very elastic, then the length, you see, before stretch, everyone is taut. So after I hang the weight, when I'm hanging the weight, you can see, oh, this one is stretched longer. This one stretched shorter. When I remove the weight, this one has been strengthened. It's called strengthened. It was strengthened. It becomes longer than the original lengthened. Because okay, right. Then this one, it goes back to almost the same length. So that means this one is more elastic, right? The elasticity is better. So now they ask you, state the type of rubber X and rubber Y. Easy lah. What is rubber Y? The more elastic one is called vulcanized rubber. Then X is natural rubber. Of course, you can also write unvulcanized rubber. Basically, unvulcanized is equal to natural rubber. Just in case they ask you, I mean, like they change the word, you have to know unvulcanized is natural. The way of how they come out came out is they change the word. Then students will be like, oh shit, what is unvulcanized rubber? What I never learned before. It's actually natural. They can ask you to give characteristic of unvulcanized rubber, soft, easily oxidized, and compare and explain the difference in average increase in the length. So let me mention the difference first. The average increase in length of rubber Y is shorter than rubber X. Okay, why? Because rubber X is more elastic than rubber Y. In the open sentence, make the comparison. Okay, so so far we got 4 marks already. Why not Y more elastic? Wait. Sorry. Why cannot? Wait. Okay. Okay. Rubber Y is more elastic than rubber X. 3 marks already, 4 marks already, sorry. One mark, 2 mark, 3 mark, 4 marks. Then another 2 marks is what? You have to tell them more why, right? Why rubber Y is more elastic? Sulfur cross-link can pull the polymer chain back to original position. Okay. The vulcanized rubber contains sulfur cross-link in between rubber polymers. Okay. It's everything that you have read. So shoe soles can be made of rubber X and rubber Y. Which rubber is suitable to make the shoe soles that last longer? So last longer, then we have to use Y law. Give 2 reasons. Why? Why use rubber Y? Why we do want to use X? We use Y. More elastic, more elastic, harder, not easily oxidized, and then resistance to heat. Okay, like that, just throw the opposite answer. When they say bad thing, you give the 3. When they say about good thing, vulcanized rubber, you just give the valid answer. And then this one, state the meaning of polymer. Give 1 example of natural polymer. Okay, easy. Draw the structural formula and name the polymer B. Okay, done. Compare and contrast polymer A, polymer B in terms of types of polymerization, characteristic of the monomer involved. Okay, so this one is condensation, this one is addition, this one is at least 2 types of monomer, this one is 1 type of monomer, 2 different functional group. This one is a double bond between carbon. And yeah. Characteristic. Wait, compare and contrast. Characteristic of the monomer. Yeah, like that. Okay. Next. Namakan monomer bagi polyethylene dan polypropylene. That means monomer, ethene, and propylene. Lucas structure monomer. So monomer, remember, students, monomer don't put N, no N, double bond without N. Only the polymerization, the one you showed it becomes something one, you have to put N. So bagaimanakah pelupusan bag plastik dan bekas plastik menyebabkan pencemaran alam sekitar? So how can disposal of plastics causes environmental problems, pollution? Pelupusan bag plastik. Plastik 是讲 how do we actually get rid of plastic? Ya, wait ah. Hello. Ah, siapa? Ada meh? Mana ada? Tak ada, bukan saya ah. Bukan nombor ni lah. Bukan saya. Okay, okay, bye bye. 奇怪，还我说打给他，谁打给他？OK，来，我看啊，我在教书，我打电话，我那个谁，OK，来，他讲017打给他，我讲好心，只有我一个人用017，OK，来，这个 OK，OK，来，OK，sorry。I mean like, sorry, nothing happened. Okay, wrong number. Oh yeah. Okay, the way okay, see just now you actually mentioned something. Okay, incineration. Incineration means burning. Okay, normally how we get rid of plastic is we burn it. Okay, we burn it, we landfill it, we throw it into Malaysia, we throw it into Longkang, we throw it into wherever. Okay, so here we will say that. So disposal of plastics by open burning releases toxic gases. Got S1, release toxic gases, which can cause air pollution. Okay, or you can say what greenhouse effect. It causes greenhouse effect, global warming, and then you can also say simply throw plastic. Simply throw, how to write simply throw the plastics can cause this flash flood lah. Okay. Ataupun tempat pembiakan nyamuk. What do you call that in English? Tempat pembiakan nyamuk. Happy birthday for the mosquito. A breeding place for mosquito. You can write okay, anything about environment, you just put it in. Okay, really, it's like that one. Every time when they talk about plastic and environment, this is what you write. Habit for breeding mosquitoes. You all right, okay? Okay, so basically, this one cause air pollution or greenhouse effect. You have 2 marks already. 1, 2, 3. Okay, and then this one is like mosquito and the flash flood is another 2 marks lah. And then this one all done already. Just the natural rubber. Huraikan secara ringkas bagaimana bahan X. This one no need lah. Coagulation of latex. Then this one natural rubber, vulcanized rubber. Then here, one example of product made of rubber wine. Give one example, please. Car tires, okay, tires. Yeah. When rubber X is heated with sulfur, rubber wine is produced in the process of vulcanization. Different characteristic, more elastic, resistance to heat, not easily oxidized. This everything you can write. Then I think nothing very special already. 2 uses of polymer X. 2 other uses of polymer X. Polyethylene. Polyethylene, other than plastic bottles, it can be used to make plastic bags and yes, food packaging, Plastic containers also can, toys also can, toys also can. Food packaging is not the polystyrene. This is the transparent one. When you open the cover, it's like like that. That one. Okay. Okay, nothing very special about this question. How latex obtained from the tree can be state. Compare the difference. Okay, rubber gloves and okay, this one nothing special. Okay, same thing. Okay. No more. Hey, what's this? Let me see. In your opinion, do we need to support the campaign shown in diagram 8.1? Yes, settle yourself on this one. Support the campaign or not? Why support? Why support? The recycle campaign, I think. Practice proper waste disposal. Recycle. Why? Environment. Okay. You can say reduce pollution. You can reduce pollution. You can preserve natural resources. And then sustain the environment means you preserve the natural resources. Make sure you all can survive like that. Good things you all very good one. You all can do English essay, then you all can do this one. So what is this? 4 juta tan sampah. What they want? Oh, student, you see this one. The difference between this question and this last question already. This one and the wastewater just now. This is solid waste. Solid waste means rubbish. Solid waste. Just now is industry wastewater. Wastewater, we use electro coagulation to treat it. That means like filter it. But solid waste, how we do it? Let me find the picture or not. This one. It's also about waste management. Most highly green technology is going to ask you about waste management. For industry wastewater, electrocoagulation. For solid waste, we can do these 3 things. Recycling, methane gas recovery, incineration. Incineration is actually burning the substance, but maybe with some air filter, something like that, they will that is better than open burning. So what do you want? Or 2 methods involving the application of green technology to solve the problem. It can be incineration, recycling. Wait, how to spell? Incineration. Methane gas. What collection? Recovery. Methane gas recovery means rubbish when they decompose, they produce the methane gas. We collect the methane gas and use it as fuel. Okay, just like that. So remember nanotech. Nanotech, you can talk about cosmetic, your food, easier to absorb by the body, medicine, easier to absorb by the body, or microchips, semiconductor that has better electrical conductivity, nanotech. Green tech got 2 waste management and also this kind of thing. Solar energy, the solar thing. wind energy. I mean, you remember like one like that, lah. Okay. Just like that. No more. Okay. So actually, a question here, students. We still got Form 4 Chapter 8. Are we going to have extra class later, like tonight, or no need? Do we have to do Chapter 8? Can okay, can let me think 11 can 10 to 11 like that. I don't know when you study okay, when you study pay more attention on for AC all the formation of bonds all the formation of bonds, and then chapter 6 salt acid this one cannot skip lah, Emma. Form 5 chapter 1, and your Form 5 chapter 2. I think most likely going to come out this for AC lah. Rate of reaction came out in AC, I think in the past 2 years already. So rate of reaction this year, I don't think will come up in AC anymore. And then I think polymer or the food, medicine, all this has a very high chance. Soap and also alloy. If they come out AC, they will join question together lah. We do know. And then for soap and detergent, past 2 years also came out already. So I think this year's chances of coming out soap is very small. Okay, usually they spam a lot in the state paper, never come out one. It is like this year they spend a lot of soap detergent. I don't think it will come out. I don't think lah, but then if it come out, don't blame me lah. And then for structure questions, must know how to do empirical formula. MgO, CuO. That one. Chapter 4, please study period 3. I think they will either ask you overall or they ask you period 3, or maybe the one that seldom come out, group 17. Last year came out group 1 already. So I think period 3 lah, most likely. Group 18 Group 18 doesn't have much question to ask. So normally group 18 they mix with others one. Not just period 3 maybe they can mix questions we don't know lah. Overall or period 3 I don't know. Chapter 5, chapter 6 experiment section C experiment need to read all. Experiment I can only say I don't know experiment. You see let's say AC really come up from all this topic if okay, then chapter 6 they can ask you a lot. Preparation of salt. They can ask you preparing standard solution. You know Andrew Chu tips, I don't know. Lee supposed to be okay one. Why you got tips And then Andrew Chu last time I when I'm a student he give everything one. Then he say it's tips. Then got come out like he give 50 AC, then got one count. I said got come out. I also can okay. I mean like just go through everything chapter 1 is like it can come out electroplating law, purification. If come out electroplating, purification, they're very good law. But I think the chances is quite small because your paper 3 came out voltaic cell already, so I don't think they will ask you to do voltaic cell experiment anymore. So it can be electroplating, purification. Then this one is esterification. I write okay. Purification, electroplating. YouTube also is one of the like popular experiment to count in section C. Then this is esterification. Chapter 2 is esterification only because just last year just came out dehydration. So I think this one will not, this chapter chances very small. Okay, then if this one are alloy, the hardness of alloy, you drop the weight on the ball bearing one. Standard solution. And then this one salt, GG salt, everything now. Preparation of salt. The 7 test tube one also can. Like that law. I think okay, I don't know lah. We pray lah, okay, hopefully just like that lah. Bye bye. Tonight still 10 p.m. Tomorrow English class is 3 p.m. Yes, tomorrow is 3 p.m. Tomorrow is 3 p.m. Bye bye. Got question you can ask me now. Got question you can ask me now. Then need to write what? Just procedure or material. Normally, you follow the questions. Normally, they just ask you to write procedure, just procedure. Need to draw? No need to draw. Procedure no need to draw unless they say draw the diagram. If you doesn't see the word draw the diagram, 如果没有看他这样讲，就不用画。Okay, got question then you stay, no question, bye bye. I open my ask 来 ask。
老师你听到啊？
听到。
那个 Form 4 Chapter 7的就有时候还会出很像那个concentrations还有 volume 有时候不一样的嘛，等我们要画出那个 graph 出来嘛。
Yes.
就那个graph 我们是不是看 gradient 我们是看那4个 factor， 就是那个temperature size concentrations， 还有那个catalyst。Yes. And then 那个volume 我们就直接算那个 number of mole， 看哪个比较多就比较上面。哦，等一下。等一下。
这 student 阿 Win 我找一个 YouTube video 给你看啊。
还有老师，我 send 你一个问题，你帮我看一下可以吧？
可以。
就是这个3秒。就那个 FeO 是 brown color 的吗？不是 green color 吗
？Brown solid for ammonium gas, X2 nitrate green precipitate. something treat Fe and O32. Then down with precipitate Fe OH2. 这种
nitrate。
你看他讲 ammonia solution is solvent Y 嘛 ，ammonia solution is solvent Y 就是 ammonia solution 掺水嘛。然后加 X nitrate 嘛。Green precipitate 一定是 iron 2嘛。所以它 iron 2 nitrate 那它做到的 precipitate 是 iron 2 hydroxide
啊，那个旁边那个 brown solid form 咩 FeO 是 brown color 的咩
那是 Fe2O3 吗 ？Iron 3 oxide 吗？
？Iron tree oxide。
啊，
等一下啊，
好的咯。
它的 product form 是 FeO，and then 加 NO3 NO2 再加。
不是啊，应该是 Fe2O3，不应该是 FeO 的。
Then 可是那个旁边那个 X nitrate solution， 它用的不是那个 iron 2 nitrate 吗？
哦，是一起的。
我不懂哎，我觉得是一起的嘞，像就因为那个 set one 的是那个 iron 3 nitrate 嘛，是不是？
或者是如果是 X nitrate 的话，等啊 FeNO3 2 heated brown solid form，brown gas brown solid form， 那好像是有这个 reaction 的也是 Fe2O3 加 NO2， 就是我忘记是 3 会产生 2 还是 2 会变成 3 也是有这样子的 reaction， 就是我忘记是哪里的，其中一个是这样子的 ，2 它可以变成 3 oxide 的，所以 I think maybe 是这个吧。
哦，就是不是普通的那个像 FeO 加 NO2 加 O2
这样就
那
不是哦，这样就不是，我记得好像是有啊，你给我找一下啊。这个会也是会 produce Fe2O3 的有。
哦，OK，所以就是那个 X nitrate 就是iron 2 nitrate 咯。
啊，对。
OK，Thank you。
阿 Win 啊，看 video 阿 Win，Win 你看了你应该会明白的，你看不明白再跟我讲。Basically 这个就是讲hydrogen bond 嘛，它 hydrogen bond 它 form 了过后哦，水会 form hydrogen bond， 可是当它是在固体的时候哦，它的 hydrogen bond 很 stable， 它中间会有空位啊，你看这个就明白了，你看这个 video 就明白。所以有那个冰山哦是浮在水上面的，所以就会跟这个问题一样，我们的冰块浮在水上面，为什么呢？为什么 solid 会浮在水上面？是因为它中间有空气啊，你可以看到这个。OK， 拜拜，再见。我现在有教书啊 ，sorry，2点有教书，拜拜。